Hello everybody, today I'm going to talk about evaluating quadratics. Evaluating is something that we have done before. I just want to make sure to review it with you before we move into chapter 8, which is graphing quadratics. So let's take a look at what I am going to talk about today. So the first thing is I want to talk about the directions evaluate. In mathematics, whenever you see the directions evaluate, the meaning behind that is they want you to, you're going to find a numerical value for, say, the expression, or variable, which will be the case in the problems that I will be talking about today. Whenever you see the word evaluate, think the word value. So always think value, think find the value of. Okay, so that's a good way to sort of think about the word evaluate. All right, let's look at an example. So in each of these examples, our directions are going to be evaluate for y. So let's look at number 1. So we're going to find y when x equals 3. So let's look at the equation y equals 2x squared minus 3x plus 1. So this is what we call a quadratic. We've talked about quadratics before. We've talked about factoring them. Remember, quadratics are, we've seen them in the form of ax squared plus bx plus c. The only thing different now is I'm putting a y equals in front of it to make it an equation. Okay. Remember, quadratics have a degree of 2, which means the highest exponent is a 2. All right. So what you're going to do whenever they give you an x value and they're asking you to find, say, a y value, is you're going to substitute in the value of x, which in our case is 3, wherever you see x in the equation, and leave everything else exactly where it is. Now, to represent multiplication between a coefficient and a variable, there's no symbol there. But since I have a number times a number, I recommend using a parentheses. Okay, you definitely do not want to use an x to represent multiplication because we have variables x and that can get confusing. All right, so continuing on with the problem, now we're going to use order of operations. The order of operations tell you to do grouping symbols, exponents, multiply or divide, left to right, add or subtract, left to right. Okay, so I don't have any grouping symbols, so I'm going to go with exponents, and that means I need to square this 3 first. Do not multiply first because that would not be following this order. 3 to the second power is 9. So now I have 2 times 9 instead of 2 times 3 to the second power. I don't have any division, but I do have multiplication. So going left to right, I'm going to multiply 2 times 9, multiply negative 3 times 3, and just bring down the plus 1 as we continue on with the problem. Then you're going to continue with adding or subtracting. Remember, both of these, multiplying, dividing, adding, or subtracting, you should always do those left to right. So I'm going to do 18 minus 9 is 9, and 9 plus 1 is 10. So the answer to y equals 10. Now, what does this answer mean? What this answer means is if we think about an XY chart or a T chart, the value of x is 3, and when x is 3, y is 10. Really, what we have done is we have found an ordered pair 3, 10. This is a point on the quadratics graph. So if we were to graph y equals 2x squared minus 3x plus 1, you would see that on that graph, this point would exist. We could find more points by plugging in other x values and solving for y. Let's move on to a second example. There are other ways that quadratics can look. Another way a quadratic can look is y equals negative times the parenthesis x plus 5 to the second power plus 6. So for this problem, we're going to find y when x equals negative 2. So in the place of x, I'm going to put negative 2. You can see everything else, I'm writing it exactly how I see it. Now in this problem, we do have some work to do inside the grouping symbol. So I'm going to work with that first. Negative 2 plus 5 is 3, square it, plus 6. Next I have exponent. This negative in front, we'll deal with that later, but remember a negative in front means you have a 1 there. So it might not be a bad idea to put that 1 there, maybe even at the beginning of the problem, so that you remember you need to make sure to square and then multiply to the negative, which essentially is a negative 1. So doing the exponents, I get negative 1 times 9 plus 6. Then we have multiplication before addition. Oops. So we get y equals negative 9 plus 6. So I get y equals negative 3. That means if you were to graph this quadratic, the point negative 3, negative x's. So that means if you were to graph this quadratic, when x is negative 2, y is negative 3. It means that the point negative 2, negative 3 would exist on the graph of this original quadratic. So number 3 is for you to try. So after I write the problem, pause the video and give it a try. The equation is y equals 2 times x plus 5 times 2x minus 1. So the answer to this one would be y equals 242, meaning that the point that would exist on this graph, it's a really big point, would be the point 6, 242. So, hope you enjoyed this video, and good luck with your practice.